It says Shelly bikes 21 miles in 4 hours. What is Shelly's average speed in miles per hour? Well, average speed is just how much she travels, like, in total, and you know that an average you just divide pretty much. So for this one, it's just pretty much asking you like how much is she traveling per mile? I mean per hour. And
Yeah.
you know that in order to do that, 21 miles per 4 hours, all you have to
You
do is
basically
divide.
divide.
You divide.
Yeah.
Yeah. And when you divide, I don't know if you'd have your calculator for this one just because it's not too bad, but I will tell you that you should get 5.25. Oh, 5.25 miles per hour. So that's the answer to that one. I don't think this first part was too bad.
Yeah, that's easy.
And then the next one. The next one is kind of going to the idea of the relationship. So that will be really important. Just because it's really good to do notice the relationship because it just means that you're understanding the math better. So let's look at part B. It says at the same rate, so she's traveling at the same rate of 5.25 miles per hour. How many hours will it take Shelly to bike 42 miles? So there are many ways to do this, but I think setting up the proportion is the easiest. We know that she travels 21 miles in 4 hours. And that's a 1. 21 miles in 4 hours. I don't like how that looks. 21. And then it's asking us how many hours it takes her to travel 42 miles. So that's what we're missing. Go back to the idea of the relationship. It looks like the relationship between this is times 2 and times 2,
Yeah.
right? Because it goes from 21 to 42, 4 to blank. So 4 times 2 is 8 hours.
Yeah, because
So that's
21
your
is half
answer.
of 42. Yeah.
Yep, exactly. That's your answer.
This
And that's
question
how,
was easy.
yep, that's really how easy it can be. So, but again, for example, if you did not notice that relationship and you just went away to solving, you have to cross multiply, like I've been saying. You would do, this can just be an x. Oh no, sorry about that. This can be an x. You cross multiply. So you get 21x is equal to 42 times 4, because it's 4 times 42. You get 168, and then you divide by 21 on both sides.
Does it matter if like the answers you put it like at the bottom? You since you do it at the bottom, is it like does it matter if you do it at the top or no?
Oh, okay. So like you're
Would it
asking
matter?
like if are you talking about like this part over here, like the one that I'm gonna circle it in yellow, like over here. Oh wait, sorry, over here, like cause I put it at the bottom there. Is that what you're asking or no?
No.
Okay, so what are you asking?
I'm saying that when you did the little circles to do the cross multiplying,
Okay.
can I write on it so that
Yeah, sure, go
I know how to
ahead.
explain it?
Yeah, circle
When
it,
you
whatever
did
you're
this
asking. Yeah.
and you put the answers over here, it doesn't matter if you put them up top or
Oh,
no.
okay, so the reason why I put them on the bottom is normally because like on the page, I usually write this first. Like pretend you have like a blank piece of paper in front of you or like a test or something. I usually just write the fractions first, and then like on the work down is when I just like because when you're doing math you're supposed to like work down. So that's why I just write it on the bottom. So
Okay.
that's I don't think it truly matters, but you know, it's kind of just a preference thing. So yeah. So let's see. That's really how you do that problem, but it wasn't too bad, like someone said. So I'm just going to clear the screen and move on to the next one. A lot of these can be solved with the relationship, so keep that in mind when you're doing it. All right. So number 2 says, mark true or false to indicate whether the ratios are equivalent or not. So when you have ratios, I think the best way to see if they're equivalent is to simplify the fraction and see if they're equal. So let's look. it says 3 over 16 and 9 over 36. Or you can also notice if there's a relationship. So let's see. There's two ways to do it. Simplify or notice if there's a relationship. So 3 over 16 and 9 over 16. In order to get to 9, you have to do times 3. I realize I wrote the 16 instead of 36. And so in order to get to 9, you have to do times 3. In order to get to 36, it's going to be 2 point something, just because I know that 36 or 16 times 2 is 32, and then it's a little bit more. But these numbers are not the same. In order for it to be the same ratio, it has to be the same relationship, right? It has to be that same idea. If they're two different numbers, then it can't be true, because it can't be simplified. Those are not the same. And if you're ever unsure, and if you have your calculator, you can just divide these fractions and see what you get. And if they're different, they're not the same. So 3 divided by 16 gives you 0.1875. 9 divided by 36 gives you 0.25. They're different. They're not equal. So that has to be false. So how about the second one? Can anyone tell me that one? What do you guys think about that one?
It's true, because 6 times 2 is 12 and 9 times 2 is 18.
Yep, perfect. So that's exactly how I would have perceived it. Really, you have to notice the relationship, as I was saying. It's times 2 times 2. It's true. So that one was pretty easy. How about the next one?
It's
the way that
also
we're doing
true,
it right now.
because 10 times 3 is 30 and 5 times 3 is 15.
Exactly. So again, I'm just gonna write it on the paper just so it's easier for you guys to kind of see what he's saying. He noticed the relationship is times 3. So 10 times 3 is 30. 5 times 3 is 15. So that one is true. And
So
then
this
how about the
type
last
of
one? Type of what?
this way that we're learning it, like that we're solving the problems, is that the simplifying or the finding a connection?
Oh, we're finding a connection. That's the one that we're doing right now. So
Okay.
for this one right now, I will simplify it right now just for you guys to be sure. I'll show you guys the other way, because I think the simplifying way works good for the two that I have blue circles next to. So the simplifying way for those, this is the finding the connection way. The simplifying way, all you have to do is make it this, you have to reduce the fraction. So 6 over 9 and 12 over 18. 6 over 9 can be reduced to 2 over 3, because you can divide by 3 for both. That's a 9. And then for this one can also be reduced to 2 over 3, because if you divide by 6, you get 2 and then 3. So they're equal. And that's the simplification way. For number 2, let me erase this. But for number 2, you just have to simplify. So 10 over 5, 30 over 15. 10 over 5 is 10 divided by 5, which is 2. 30 divided by 15 is 2. So they're the same. It must be true. That's what we're checking off. So that's kind of the other way to do it. I kind of did it over here when I divided them in my calculator. And I'll do it over here for the last one, which is what we're missing. So I'm gonna draw a line and show it to you both ways. The simplification way: 16 over 3, 32 over 9. All you have to do is divide 16 divided by 3 in your calculator. When you do that, you should get 5.33, repeating. And then 32 divided by 9, that's pretty much what you're doing. It's just you're reducing it and simplifying it to see if you get the same one. 32 divided by 9 is 3.56. Those are not equal, so I know the answer is already false. But let's check it the other way, just in case we didn't have our calculators. 16 over 3, 32 over 9. The relationship on the top is times 2. The relationship on the bottom is times 3. They're not the same number. There's no relationship. It's false. So that's how you can kind of tell. So hopefully these problems were not too bad. And hopefully both ways kind of make sense to you. So remember, if you have any questions, just unmute yourself, let me know. But I haven't gotten any questions, so I'm going to move on to the next one. Okay. All right. Let's see. Okay, this is kind of long. So it says Chris and Jenny are comparing two similar punch recipes. Each recipe calls for cranberry juice, and that's also say ginger ale. Ginger ale. I don't know why there's a typo, but in different amounts. The tables below show the amounts of cranberry juice and ginger ale for 4 different quantities of punch. Mark yes or no in the table below to answer the questions. All right. So each person, Chris and Jenny, they have their own ratios because they have their own recipe, and recipes call for different amounts of different items. So it looks like for Chris, for every 1 cranberry juice he has 4 cups of ginger ale, and for Jenny, for every 2 cups of cranberry juice she has 3 cups of ginger ale. And writing the little colon, the 2 dots, is just another way to write the ratio. It can be 1/4, 2, and 2/3. But I'm writing in a different format for you guys to get used to that one. So let's see what the first question says. We're marking yes or no in the tables to see if they're true. So it says, is the proportion of the punch that is cranberry juice the same in each of Chris's given recipes in the table? So in order to do this, again, it's kind of noticing the relationship and seeing if it's going to be the same ratio. So it looks like for every 2 that he has, it looks like the fraction will always be 1/4. That's what I'm noticing. Because if you write each one out, so let's see. You have 1/4 here, 2/8, 3/12, 5/20. One thing that you guys should notice about these is that they all simplify to 1/4. 2/8, it goes into 2 goes into both, and you get 1/4. 3/12, 3 goes into both, you get 1/4. 5/20, 5 goes into both, you get 1/4. So it's 1/4 for all of them. So the question is the proportion of the punch that is cranberry juice the same in each of Chris's recipes in the given table? So yes, it is the same because he's putting the same amount for each added cranberry juice. So even though the numbers are increasing, he's still putting the same amount, and he's still increasing by the same amount. And when you simplify them out, you still get 1/4. So it's like he didn't accidentally put in more cranberry juice one time. He put the same amount according to the ginger ale. So does that kind of make sense, everyone, or not really?
Yeah.
Yes? Okay. So let's try it out for Jenny. And her question is the same question. It's just asking if it works for her. So we already figured out that for every 2 cups of cranberry juice, she's putting in 3 cups of ginger ale. So that's 2/3. Now we have to check the other ones. 4/6, 6/9, 10/15. Well, for this one, 2 goes into both, you get 2/3. Okay, so that one worked. 6/9, 3 goes into both, you get 2/3. Okay, that one works too. And then 10/15. 5 goes into both, you get 2/3 again. So it works again. So that means that she's still putting in the same amount for each thing. And for you to kind of visualize it, it's like she has like this big cup. Just so you guys so you can understand like how it's working. And she's putting in 2 cups of cranberry juice. So she's putting in 1, 2. And then she's putting in it says 3 cups of ginger ale, so I'll do that in yellow. 1, 2, 3. So if she adds more to it and she adds 4, for example, so I will now extend the cup, or if anything, yeah, I'll extend the cup. So let me move my work over here. Now she has 4 cups of cranberry juice. So this will be another layer and another layer. And then now she has 6 cups of ginger ale. So now she has 3 more over here. Even though it looks bigger, it's technically the same fraction of things that are there. It's like she didn't accidentally add more cranberry juice, because then it would be like an uneven mixture. Like it would not be the same amount of like proportional mixture, because then there would be more cranberry juice. But since she's adding the same amount with each step, she keeps adding 2 over here, 2, 2, and then there's missing 1 here, but it's 4, but there's a missing 1 there. And then she keeps adding 3. It's like she still has the same amount there. So that's kind of how that problem works. All right. So we already figured out that since it's 2 over 3 for each step, the answer is yes. Now, can anyone tell me the last question, which is
it's no.
yes,
You
yeah,
can
it's
even
no.
tell. It's very obvious. You can even tell by the ratios. 1 to 4, 2 to 3. They're different.
Exactly. That's exactly what I was gonna say. It's since it's 1 to 4, 2 to 3, it's completely different. They're not the same. They would only be the same if they were both the same ratio. So it is kind of obvious. Someone was saying excuse me. So did someone have a question? Or...
Oh no, never mind.
Oh, okay. Just making sure. So hopefully that problem was not too bad. It's just about, again, finding the ratio, finding the fraction. So hopefully that kind of made sense. Going on to number 4. So it says Miss Mitchell buys a new pair of boots that originally cost $65, but are now on sale for 15% off. What is the sale price of the boots? There are 2 ways to do this. Maybe in math, and then maybe there's a way you've seen it before. If it's 15% off, in order to find a percent of like a whole, you convert the percent to decimal form. So 15% is 0.15. $65, 15% of that, you have to multiply those. So 65 times 0.15, you get $9.75. And in order to figure the new sale price, you have to subtract the discount. So you do 65 minus 9.75. And when you do that, sorry about that. When you do that, give me a second. I just need to flip to the page because I've been going ahead of myself. When you do that, you should get around $55.25. And that's the answer to this problem. But there's another way to do it that I want to show you guys just so you understand it too. There's actually 2 more ways to do it. In order to get the answer directly, you can recognize that if something is 15% off, you're only paying 85% of the cost. So what you can also do is do 65 times 0.85 because you're only paying 85% of the cost. When we subtracted that number in the first example I showed you, we subtracted 15%, but really we were just paying 85%. So now that we know that we're paying 85%, we can just do 65 times 0.85. And what do we get? We still get $55.25. Now the last way to do it, you can always do it with a proportion too, just in case you're unsure. So we know that the original cost, we can represent that as 100%, is $65, and it's 100%. It's 100% of what she's supposed to pay. The new cost, the sale, we don't know yet, but we know that she's paying 85% of the cost, not 15%. 15% is the discount. 85% is actually what she's paying. And you can do that just by doing 100 minus 15, and that's how much she's paying. So all we have to do now, like I've been saying, is cross multiply and divide. That's always the steps for when you have proportions and you're doing these like that. So you end up getting 100x, I think it's moving, 100x, and 65 times 85. Feel free to do that in your calculator. You get 5525. You divide by 100 on both sides. And what do you get? The same thing. You get $55.25. So there are many ways to do number 4. Hopefully one of those ways made sense to you. Feel free to do it whichever way you want, because there's a lot of freedom with this question. You need to do it the way you understand it the most, even though it's good to know and recognize all 3 ways. So with that, I'll move on to number 5, which is a 2-part question, and it's the last question of this section, and technically the last question we'll ever do together. So all right. Okay, so give me 1 second, just so I can let someone in. Okay, so let's see. it says Roger ran 8 laps around a quarter-mile track. Quarter mile is the same thing as 1/4 during PE on Monday. Answer each question in the space provided. So it gives us a whole little table for conversions, just to make it easier for us. So it says, how many feet did Roger run in completing 8 laps? So the first thing we have to do is we have to convert the 8 laps. There's going to be a lot of converting. We have to convert the 8 laps he ran into miles. And to do that, he ran 1/4 8 times, pretty much. He's running the 1/4 mile track 8 times. So 1/4 of a mile times 8 will give you the amount he ran in total. When you guys do that, all you have to do is do 8/4. You get 2 miles. So he ran 2 miles. So the next thing is to set up a proportion. So I noticed that we're trying to find miles into feet because it says how many feet did you run. So I noticed that here it tells us how many feet is in 1 mile. So 1 mile is 5,280 feet. We're trying to find how much 2 miles is because we just figured out that if he runs 8 laps in a 1/4 of a mile track, he's really just running 2 miles. So this is what we're missing. So can anyone, sorry about that. Can anyone tell me the answer to this?
Okay, so you have to like multiply. Since he did 2 miles, you have to multiply 5,280 feet times 2, and it'll give you 10,560 feet.
Yes, so that's good. All right, so I think the way that you picked it up is that you noticed the relationship. The relationship between 1 mile and 2 miles is times 2. So all you have to do over here is times 2. And 5,280, even though it's a really big number, you're able to get it. Times 2 is just 10,560. So that's the answer to this problem. Of course, if you don't notice the relationship, and I'm happy that so far at least we've been able to see the relationships, but if we don't see it, we can always just cross multiply and divide. And for this one, I don't even think you need to divide. If this is our x, it's just 1x. You don't need to divide when there's a 1x. So it's really just 5,280 times 2 in your calculator, and you get 10,560. So that one wasn't too bad. But let's look at part B, and that's the last one we'll be doing. So part B, it says, if Roger wants to run 10 miles by the end of the week, how many more laps will he need to run this week? Okay, so it says how many more laps, and that's the key word for this problem. So I think setting up a proportion is the easiest way to do this problem, but you need to know what you're going to be putting on the fractions. So we're trying to solve for laps. So we know that he ran 8 laps. When he ran 8 laps, he did 2 miles. And we got that by doing 8 times 1/4, which we just got. Now, what we're missing now is what we're going to be doing over here. We need to figure out how many laps he's running, but don't be so quick to put 10 miles. The question isn't how many laps would he do if he ran 10 miles. The question is how many laps would he do in order to reach 10 miles for the whole week. It looks like he's already done 2 miles this week, right? He already ran 2 just from the problem. So in order for him to reach 10 miles, he needs to just do 8 more miles, right?
Yeah.
And that's what it's asking. So
Which
8
is
miles would go over here.
8 miles is 32 laps. And
yes, exactly.
Because 8 times 4, which is the denominator of the fraction of that a lap is of a mile, times 8 would be 32. So that's the answer.
Exactly. That's how you do it. And just at least with this question, it's really easy to notice the relationship, but pay close attention to the key word that it says over here. By the end of the week, how many more laps will he need to run this week? So what it's saying is that he wants to have 10 in total. He doesn't want to run 10 more. He just needs to complete the 10. And he already did 2, so it's just 8 more that he has left to do.